Okay, so this video is going to be a little bit different. It's not going to necessarily involve a project, more of a project we've already done, which is going to be this fly cutter. So there's one thing that I've always wanted to have a go at doing, and that is skimming a cylinder head. So I've never done it before, but it just so happens that one of my good friends has donated me a 4-cylinder injection engine, which I've just got sat in the back garden. Before I start stripping engines down and skimming cylinder heads, I need to find out how fast this machine is going, and I don't mean spindle speeds. So this is the power feed, and you'll usually see a power feed like this on most machines this size. And it does two important things really. One, it allows you to move the bed from one side to the other relatively quick through the use of this rapid switch. And also, more importantly, it gives you a consistent cutting speed. So if you're winding these handles by hand, you know, in some spots you'll probably be a little bit quicker, in other spots you'll be a little bit slower, and that will show in your finish. Now, a power feed like this means that you can turn the handle to one side, put it on, say, setting 1, and this motor will move this bed at a consistent rate all the way down, which is perfect for getting absolute brilliant finishes. But the problem is with this power feed is it's only numbered from 0 to 9. Now, as far as I'm aware, they don't actually put exact speeds on the dial because depending on what machine you fit this motor to, it'll have a different lead screw, which means it will go in at different speeds. And I'm assuming this will be proportional, so setting 2 will be double setting 1, setting 4 will be double setting 2, so on and so forth, but we'll need to test that as well. Okay, so this is the DRO, which stands for Digital Readout Display, and it is by far the best piece of equipment on this machine, just because the pure amount of time that this actually saves you. So it basically reads you exactly where the bed is, with a little bit of setting up, where your part is in relation to your cutting tool. So, you know, you wind it one way and it goes down, you wind it the other way and it goes up, and you can zero the axis off exactly where you need it, you know, and move it in very tiny increments, and it will tell you precisely where your part is, obviously in relation to where your cutting tool is, depending on how you've set it up. But what I'm going to use this for is I'm going to use this in conjunction with the power feed to find out exactly how many millimeters the power feed moves the bed. So I've zeroed out the DRO and I've set the power feed to 1, and I'm essentially just going to flick the power feed on and start the timer at the same time. When the timer reaches 10, I'll turn the power feed off and we'll see exactly how far it's moved the bed in that time. Uh, 2.5 mil, so we'll try that again and see if it's consistent. .6, try it one more time. .6, yeah, so it seems to be quite consistent at 2.6 mil every 10 seconds. Which is about 15 mil every minute really. So what we can do is we're going to set it to setting 2 and see if it's proportional. So if it moves 2.6 mil on setting 1, then it should move about, say, 5-6 mil on setting 2. So that's 13 mil. So that's more than double setting 1. Let's try setting 3. Okay, so 26 mil. So setting 1 was 2.6, setting 2 was 13. Now setting 3 is 26 mil. So it doesn't look like it's proportional. I think the best thing for me to do now really will be to go through all the settings, write it down on a piece of paper. So after a little bit of back and forth, these are the numbers that I came up with. So you can see that on setting 1 we're getting about 15 mil every minute, setting 5 is about 360 mil a minute, and setting 9 is about 780 to 800 mil a minute. And this is going to help massively for problem solving and testing out different things, because when I put that cylinder head onto this Bridgeport, it doesn't really need to go back together again, that engine doesn't. So what I want to do is is I want to keep taking passes and passes and passes, using different speeds, different settings, different tools, in order to get the perfect mirror finish on that cylinder. So that's the idea, and now I've got these numbers, it's going to massively help problem solving and trying to figure out exactly what we're doing, and eventually basically just see what works best. So I think the next thing to do now really will be to strip down that engine. So stripping this engine down was actually quite fun until we hit these cylinder head bolts, and I just could not get them undone, and it did end up claiming a fair few tools. So in the end I just decided to mill them out Okay, so finally got it all mounted up, and this will mostly be for speeds and feeds, so I'm just trying to get the best possible finish I can get. Now, I haven't mounted this engine properly. Obviously you'd probably want to get all the twists and turns out of it if there was any. I've just cleaned it up and just bolted it down the best as I can, because like I say, I'm just going to be taking passes at different speeds to try and get the best finish we can on top of this block. So for the first pass, I've dialed in 0.2 millimeters. And I'm spinning at about 700 RPM. So it's going to be a bit of a roughing pass. I just want to try and get this all flat to begin with, and then we can go ahead and start making some finer passes. So that was a rough in pass, and it was quite rough. That was at 0.2 millimeters depth of cut, running at about 200 millimeters a minute on the feed, and it's about 710 RPM on the spindle speed. And yeah, I can definitely tell. Obviously, there's a bit of chatter. It definitely wants running probably less depth of cut with a bit of oil. And I should say before we go any further, this is actually cutting a diameter of 9 inches. So this cutting edge is cutting a diameter of 9 inches, and the inserts that I'm using for this particular one are DCMT. These type of inserts here, just you find them on eBay quite easily. Just DCMT inserts, and they have got some speeds and feeds actually on the back. Okay, so another thing I'm just going to quickly do is just brush on a bit of oil, just to help it cut. Okay, so for this run, I've just heightened the bit a little bit and tuned that in a bit more, just so it's a bit more stable and steady. I've also halved the depth of cut down to 0.1 millimeter, and I've also put the power feed on setting 2, which is about 78 millimeters a minute. And obviously the RPM is still on the same, which is 700. So we'll give that a go. So that was 0.1 mil depth of cut, 78 mil a minute on the feed rate, and 710 RPM on the spindle RPM. And that's the type of finish that we're getting. Okay, so that last cut was pretty decent, and I basically dialed in exactly the same. I've just added an extra 50 RPM to the spindle speed, so it's a 0.1 mil depth of cut, 78 millimeters a minute on the feed rate, and 750 RPM on the spindle speed. Okay, so that's the one from that pass, and I wouldn't say it was quite good, but it wasn't as good because the finish was better, but it also came out with a bit of chatter in it as well. You can see sort of like interference marks along the cylinder head. I did actually want to change the tool in the fly cutter, maybe it was something a bit beefier like this, but the problem is this really needs to stick out a little bit because the fly cutter is just not big enough. And as it turns out, this lathing tool sticks out just the perfect amount and able to cut this head. So I'm sticking with this. I'm sticking with this cutter now, which is the DCMT carbide inserts, and I'm just going to stick with this one as I'm getting quite a good finish with it. So the speed on the spindle is going to be about 780 RPM, and the feed rate is going to be about 78 to 80 millimeters a minute, and the depth of cut is 0.02, so 0.02 millimeters. Okay, so that's an up close of the pass from what we've just done, and that's the finish we're getting with the DCMT inserts, which, to be honest with you, is absolutely perfect. Really, I'm not seeing any chatter, I'm not really seeing any lines, I can't feel any lines. So I've got the same depth of cut, 0.02 mil, and the same feed rate, about 80 millimeters a minute, and I've just turned the RPM up to 900, so it's an extra 100 RPM increase, and we'll see what sort of result that gives us. So it doesn't look too bad, but as soon as I started the cut, I could tell that 900 RPM was just way too much for this fly cutter. I was getting quite a lot of vibration, so I decided to speed up the feed rate in order just to try and put a bit more cutting force on the tip and reduce that chatter almost. And it sort of did work, because when I reduced the speed of the feed, the bit sort of creates more of a rubbing action against the material and creates more vibration, whereas if you speed up the feed, you've got a bit more cutting force on your cutting tool, and you can actually reduce the chatter by a small amount, which I did manage to do. But obviously it's left some quite, it's left lines in it, basically. Right, so I've got it back at 800 RPM, depth of cut 0.02 mil, and the feed rate is just a smidge under 80 millimeters a minute, so somewhere around the 75 to 70 millimeters a minute on the feed rate. Well, I'm quite happy with that finish, to be honest with you. That's another good finish. I'd say it wasn't quite as good as the other one though. I think 80 millimeters a minute on the feed and 800 RPM seems to be pretty decent. Okay, so this time I ran the exact same cut at 0.002 millimeters depth of cut, 78 millimeter feed rate, or just underneath 78 millimeters a minute feed rate, at 800 RPM. But I've been getting vibration through this disc. Now, I initially thought it was because of the length of my tool, and I cut that tool down, but I'm still getting quite a lot of vibration, and it just sounds like the disc itself is vibrating. So I believe that the actual geometry of this disc is why it's vibrating so much. And basically what I've done is I broke up a bit of sponge and essentially rammed it into all these holes. Just adding this little bit of sponge into each one of these holes is pretty much sucked up all the vibration that this thing's creating, and as a result it's left an absolutely brilliant finish on this cylinder head. So I think that's probably about the best I'm going to get it, to be honest with you. Okay, so this is definitely the best pass so far. It was about 0.01 millimeter depth of cut. The RPM spindle speed was at 1160, and the feed rate was on about 15 millimeters a minute. And I've just given it a little clean up with this rag, and you can see just how shiny it is. I think that's the best I'm going to get, to be honest with you. So thank you for watching, and I'll see you in the next one.